Hello, I'm your TA. In this video, I'm going to demonstrate you how to solve exercise 11.9 in How Well 8th edition. 11.9 is a calculate the eta squared and omega squared for the data in exercise 11.8 and interpret the result. Eta squared and omega squared formula is here. And unfortunately, we don't have given data. We need to calculate the ANOVA table by hand calculation by using only these summary statistics. So let's calculate the ANOVA table. This is the ANOVA table, and I copied this information from the exercise 11.8. I will say group 1 as SIT, group 2, 3, and 4. So my number of subjects in each group is, and 1 is 14, and 2, and 3, and 4. And this is my first group mean, second group mean, third group mean, and fourth group mean. If you sum them up and divide it by 4, which is 15.62, 15.62, this is my grand mean. And this is standard deviation of group 1, 2, 3, and 4. Because my formula for eta squared and omega squares are written here, so I only need to know the sum of square treatment, mean square error, and sum of square total. Let's start from the sum of square treatment. The formula for the sum of square treatment is nj times sigma. We have 4 groups and group mean minus grand mean squared. So first group has 14 times 11.07 minus 15.62 squared plus second group, there are 10 subjects, 10 times 15.4 minus 15.62 squared plus 11 times 18.09 minus if you calculate it, my result is 507.84. So we have sum of square treatment. And my degrees of freedom is number of group minus 1, which is 3. And mean square treatment is sum of square treatment divided by degrees of freedom of treatment. If you calculate it, that is 169.28. And then I need to calculate the sum of square total. However, sum of square total can be calculated as sum of square treatment plus sum of square error. So I need to know the sum of square error. But we don't have given data. We need to calculate the sum of square error from mean square error. Let's see the formula for the mean square error. Mean square error can be calculated by sum of square error divided by degree of freedom of error is mean square of error. So if I know the mean square error, I can calculate the sum of square error as mean square error times degree of freedom of error. According to textbook page 330, homogeneity of assumption, population variance can be mean square error because we don't know the population variance. We need to calculate the pooled sample variance because this case can be either different samples from one population or samples are different population. So let's review the pooled sample variance. We have two groups and sample size are N1 and N2 respectively, and standard deviation are S1 and S2. So pooled variance can be calculated as this way. So denominator is the sum of sample size minus 1, and numerator can be calculated in this way. So mean square error, my denominator is sum of the each group subjects minus 1. So 14 minus 1 plus 10 minus 1 plus 11 minus 1 plus 10 minus 1. And my numerator is 14 minus 1 times variance, so 3.95 squared. 10 minus 1, 11.12 squared, plus third group is 11 minus 1 times 7.13 squared. Fourth group is 10 minus 1, 7.11 squared. If you calculate it, this is 55.59. So mean square error is 55.59, and degrees of freedom of error is the sum of the each group subjects minus 1, which is the same as this part. So if you add 13 plus 9 plus 10 plus 9, which is 41. So here is 41. And also this is 41. So my sum of square error is 55.59 times 41, which is 2279.6. So my sum of square total can be 507.84 plus 2279.06, which is 2786.9. So I know the sum of square total. And I also know the mean square error here. Mean square error is 55.59. So let's plug in the numbers. So eta square, sum of square treatment is 507.84 divided by SS totals, 2786.9, which is 0.18. And omega square is 507.84 minus k minus 1 is 3 times mean square error is 55.59 divided by which is 0.07. So I could say, therefore, we are accounting for 18 or 7% of the variability in reported errors on the basis of treatments, depending on which measure you chose. If you have any question, please reach out to me. Thank you for watching this video.